Hello students. Our next topic is spectra of hydrogen atom. So we have one electron in the hydrogen atom. So the electron in the hydrogen atom moves in a central potential VR. It is R dependent VR, central potential produced by the nucleus. So the central potential influences the electron in the hydrogen atom. So there is a spin orbit Hamiltonian HSO, spin orbit Hamiltonian, which is given by HSO is equal to 1 by 2 m square c square into 1 by r dv by dr L dot s. So due to the interaction of L and S, you get the spin orbit interaction term HSO, right? Now for an electron in hydrogen atom, we have Vr is equal to minus Ze square by 4 pi epsilon 0 r, which is the potential energy term. So what is dV by dr? dV by dr is equal to Ze square by 4 pi epsilon 0 r square. On substituting dV by dr in the equation for HSO, Hamiltonian, spin orbit Hamiltonian, that is equal to Ze square by 4 pi epsilon 0 2 m square c square r cube L dot s. Now we have to find out what is the interaction term L dot s. We know that J is equal to L plus S. So J square is equal to L square plus S square plus 2L dot S. So L dot S is equal to J square minus L square minus S square by 2. So it can be shown that spin orbit interaction energy for a hydrogen atom is given by, when you substitute these into the equation, the spin orbit interaction energy ESO is equal to Hc by 2 Z raised to 4 alpha square R by n cube L into L plus half into L plus 1 into J plus 1 minus L into L plus 1 minus S into S plus 1. These are the magnitudes of J, L and S. You know that J is, the magnitude of J is root of J into J plus 1. So the magnitude of J square is J into J plus 1. Similarly, L square, L into L plus 1 and S square is S into S plus 1. Here we have alpha, which is called the fine structure constant value 1 by 137. Which I discussed earlier, and R is the repeat constant. R is equal to minus E1 by Hc. Okay. So as a states with different J value have different ESO. From that equation we find that for different J values we have different interaction energies, and one energy level with a specific N and L split into two levels, right, with J is equal to L plus half and J is equal to L minus half. Since there is only one electron in the outermost shell, it has a S value 1 by 2. It can be plus or minus half. So we have each energy level with a specific N and L split into two levels with J equal to L plus half and J equal to L minus half. This explains the fine structure doublet in hydrogen spectrum. Okay. Now for an S electron, if the final electron is in the S state, you know that L is equal to 0. Therefore, the interaction term becomes 0 and HS. So there is no spin orbit interaction Hamiltonian. For that case, if the last electron, the valence electron is in the S state. Now for a level with different J values. For different J values, the interaction energy, the difference in the interaction energy term, delta ESO is equal to Hc by 2 Z raised to 4 alpha square R by n cube L into L plus half into L plus 1. The difference will be only in the J value. So it is J1 into J1 plus 1 minus J2 into J2 plus 1. So this is the difference which occur in the difference in the energy level term. So we have delta ESO is equal to a constant term into delta J square. So delta J square defines the difference in the energy levels, spin orbit interaction energy levels. Now we know that the spin orbit interaction is more prominent in heavy elements. Why? Since ESO is proportional to Z raised to 4. In the equation it is proportional to Z raised to 4. When Z increases, the spin orbit interaction energy or spin orbit interaction as a whole increases with atomic number Z, or it is more prominent in heavy elements. And also from that equation for ESO we find that L is in the denominator. Right? So as L increases, delta ESO decreases. Right? That means 2p separation will be greater than 3p, and that separation will be greater than 3d separation. So as L increases, delta ESO decreases, or the separation of the energy levels decreases as L increases. Therefore, each L level other than L equal to 0, other than L equal to 0, each energy level for a given L, it's split into a doublet. Okay, so if L is equal to 0, J is only one value, that is half, and therefore S state remains singlet. For L value, for value 0, which is the state, it remains singlet state. Okay, for all other values of L, it split into a doublet for what type of elements? With one electron in the outermost shell. Now, what are the selections rules for the transition for one electron system? Delta N can be any value. For any different N value, transitions are possible, and delta L is equal to plus or minus 1 is only possible, and delta J is equal to 0 plus or minus 1 these are the three selection rules for transition for one electron system, outermost electron 1. Now, by that selections rule, the different series, we get different series as if we have a transition from N1S to N2P, a transition from S to P where N1 greater than N2, right? When S transition to P, we get doublet states. That series is called sharp series. Okay. Now, if the transition is from P to S, where N1 can be greater than or equal to N1 can be greater than or equal to N2. That is because delta N can be any value. P to S is possible. That gives a doublet state. That set of spectral lines is called the principal series. Okay. Now from N1D to N2P, D to P transition. Right. So N1 is that can be greater than or equal to N2 is possible. So we get triplet states. Okay, that transition or that spectral series is called the diffuse series. Similarly, from F to D, N1F to N2D, they form triplet states. When N1 is greater than N2, we get the triplet states. So due to spin orbit interaction, the electrons behave like a small magnetic dipole. Okay, this magnetic dipole interacts with the internal magnetic field produced by the nucleus and give rise to a potential energy to the electron. So due to spin angular momentum, the electron behaves like a small magnetic dipole, and this magnetic dipole interacts with the internal magnetic field produced by the nucleus and give rise to a potential energy to the electron. So this potential energy is different for electrons with J equal to L plus half and L minus half. Hence we get the fine structure splitting. Okay, this is the reason why the levels get splitted. So the doublet separation delta nu between J is equal to L plus half and J is equal to L minus half states is delta nu is equal to C Z raised to 4 alpha square R by N cube into n cube L into L plus 1. So this is independent of J. Therefore, doublet separation depends only on N and L. It is independent of J. So in this equation, we don't have any J value. So it depends only on N and L values. So the doublet separation depends only on N and L value.